Okay, folks, so want to get into a little bit more of the detail on petroleum and coal. Specifically with petroleum, I want to talk about what's involved with exploration, extraction, and processing. And then with coal, really what we deal with here in terms of generating electricity. Coal is the major source of electricity in the United States, so we'll pay kind of close attention to that. Okay, so for petroleum, you can't just go dig a hole in the ground and expect that oil is going to start kind of coming up out of the ground. So there are professions within geology where people are trained to understand the geology of regions and what sorts of rocks are typically associated with petroleum deposits. Now, when I was a kid, how many of you watched Beverly Hillbillies? The original one. Somebody sing the song for me? Yana?
Let me tell you a story about a man named Jed.
Poor mountaineer, barely kept his head. Okay, one day shooting at some food, up through the ground came a bubbling crude.
Oil that is.
Oil that is. Okay. How did I know you knew that song? When I watched the Beverly Hillbillies when I was a kid, I assumed that the oil under the ground was in like gigantic caverns, because you heard about oil reserves, and I thought there were like pools of liquid oil down under the ground. And that's not really what it's like. It's actually much more like a sponge. Now, not a real sponge, but rocks vary in how permeable or how porous they are. Some rocks, there are different types of rocks, so there are rocks that form from volcanic activity, that's called igneous rocks, and then there are rocks that come from other rocks that are crushed and pressured. Those are called metamorphic rocks. You don't have to write this down. And then there are sedimentary rocks, which come from things layering down and forming sediments. And if you form a sediment from a lot of sand, you'll get something like a sandstone or maybe a limestone. If it comes from mud that's compressed, you'll get like a shale. And those particles are different sizes. And when a rock is formed, and if you look at it microscopically, you can actually see that the grains of the rock substance are compacted. But so if these are the actual mineral components of the rock, oftentimes you will find little spaces or little pores. If there's a petroleum-containing layer of rock, that's where you find the petroleum, or the petroleum. But typically what happens, so let's say here's the surface of the Earth, you will often get layers of rock that vary in how porous they are. So for example, you might get a porous layer here, and an impervious layer here. The impervious layers are like clays or shale. And the porous layers would be maybe sandstone, or limestone. And then you might get another impervious layer here and another porous layer here. Typically you find the petroleum in the porous layers. So if you're a petroleum geologist, you're looking for certain types of rocks in areas where these petroleum deposits are likely to occur. So that's kind of the exploration part. You have to know where it is. So you find an area that you think is fairly promising, you drill a well, it bores through like a layer cake going down through these different layers, and finally you hit the petroleum layer at that point. This is a lot of rock. It's pushing down, there's a lot of pressure. It's down deeper, so it tends to be hotter. Okay? So it's almost like opening up a bottle of soda. It's under pressure, and once you release that pressure, if it's true for this particular layer, it'll come out, and you'll actually get kind of a gusher coming out. Yeah?
You said the oil comes from the porous?
Porous. Tends to be in the porous layers. Now certain shales will also, you can have oily shales, but that's a different procedure for getting that out of there. So we have shale oil, that's a little bit different. So at first, when you first find an area that's productive for petroleum, you really don't have to do much, okay? So, so for primary extraction, either the oil, it just comes out on its own,
So this oil or petrol?
well, it's the same thing. Yeah. So it either comes out on its own, or you apply a pump, like those derricks that you see going up and down. Everybody look, did you see that post I put up? See that little clip when we were out in Kansas? Did you guys see that? Okay. So that's oil that's being pumped out. So that's called primary extraction. It's cheap. After a while, the pressure down here gets equal to the pressure up here. Just like that's like your can of soda pop going flat. The pressures have equalized. And therefore, there's still oil down here, but now you have to start spending a little bit more energy to get it out. And that's called secondary extraction. What you do is you drill other wells next to the well that you have. So if you're looking down on it, here might be your well that you're actually taking the petroleum out of, and then you drill these secondary wells around it. And what you do then is you force water, you pump water down into the well. What happens if you have a bottle of salad dressing and you just put the oil in and now you pour the water in? What rises to the top? The oil, okay? So if you force water down, it's going to drive more oil up. Okay, so that's called secondary extraction. It is more expensive. Obviously, because you're having to operate pumps and get water and drill the wells, and all along the way you're spending money. Yeah, Fernando.
How harmful to the planet is all this? Like, is it going to add up one day and like?
The water part, not much. You're
Drilling
not
wells.
mixing anything into the water.
Yeah.
Now, when we talk about fracking, that's different, because they add chemicals. and other things that, and fracking is hitting other layers than petroleum-containing layers. So that's something different. We will talk about that. Well, eventually, even driving down water at some point gives out and you can't get more petroleum out. And if you have enough resources, you can actually do what's called tertiary extraction. And now, instead of pumping down water, you're pumping down steam and carbon dioxide. So here, at the most, you're just doing some general pressure pumping. Secondary extraction, you're forcing water down. Tertiary extraction, you're forcing down steam and carbon dioxide. And this is the most expensive. Because you gotta spend the energy to make the steam. Steam just doesn't, you have to spend money to boil the water to make the steam. You have to get the carbon dioxide, so it's more and more expensive. And then if you examine what you're getting from this, the primary and the secondary extraction only give you 33% of what's down there. So if you take the primary and the secondary, it gives you 33% of the petroleum in the ground. If you add the tertiary, you can get another 10%. So altogether, with everything that you can do, you're only going to get roughly 43% of what's found in the ground. And this is what's technically feasible. Now, could you dig a huge hole and get more? Sure, you could, but nobody's going to spend that kind of money. Now, let's think about what's happening here. The early stages are fairly cheap, and the more involved you get with this, the more and more expensive it gets. So you have to actually use energy to get energy. And this, of course, is going to be determined. This is going to be influenced by the cost of energy. So everybody's talking about gas prices dropping now. Some places it's below $3 a gallon. So people are thinking, hey, gas is getting cheaper. But then, of course, the petroleum that you get, you have to sell. So if the price is low, you're not going to be getting much for the petroleum that you get out of the ground. So at some point, there might be a break point where, for example, a company can afford to spend this much energy, but they're just not going to get the payoff in what they can sell it for if they go to, say, a more expensive form of extraction. So there's what we have to think of as technological feasibility, and then we also have to think about economic feasibility. We have a term called the proven reserves. And a proven proven reserve is the amount of oil. So people talk about, for example, the Arctic National Wildlife Refuge, or the North Slope above the Brooks Range in Alaska. A lot of petroleum-bearing deposits there. A lot of controversy whether we should exploit them because it's a scenic area, there's a lot of wildlife, it's pristine. There's a constant argument how much of those areas should be utilized. So the geologists go out there and they say, okay, what is the proven reserve? And the proven reserve is the amount of petroleum in the ground asking about this last time. So it's the amount of petroleum in the ground that can be both technically and economically extracted under the current conditions, those being economic conditions. The technology for this hasn't changed that much. So the technological feasibility isn't changing, but the price of fuel is changing. And therefore, these conditions are going to vary. When fuel is expensive, it pays to do expensive things to extract fuel. That's why these oil sands in Alberta are being utilized. When I first started teaching this class, part of what I said was it's not economically feasible right now. Gas was selling at $1.50 a gallon. Gary?
That third extraction, what is that?
Tertiary?
Well, does that fall in the technically feasible, or is that depend on the company?
That depends. No, this is technically feasible.
The
Tertiary.
okay.
Yeah. Now, it may or may not be economically feasible. Okay, so that's an important distinction. So when people say, oh, there's, 500 million, our proven reserve is 500 million, that's how much oil under the current price structure and under the current technology, how much we can get out of the ground. It doesn't say how much is down there. Notice that we're leaving more than 50%, 57% is still in the ground. We're not getting that out. So that's just something to keep in mind. Okay, so that gives you a sense of what, just the extraction part of getting gasoline into your tank, what those people are dealing with in order for you to do that. Now, what comes out is crude oil, just basic petroleum product. It varies from around the world. There's light crude, there's heavy crude. Some people talk about sweet crude. Because this is a product that was formed from, the bottoms of oceans, the bottoms of large lakes, the sedimentation of plankton that decomposed in anaerobic conditions. So it varies from place to place. It depends on if it's a freshwater deposit, if it's a saltwater deposit, what part of the world it's in. But when it comes out, it looks like a goopy, tarry substance. And you should realize that on a molecular level, there are big molecules in there, and then there are little molecules. So they're all called, what we call the general category of molecules that are found in petroleum. Hydrocarbons, okay? So hydrocarbons come in many different kinds. And yet gasoline is a subset of those. So you've got you know, any number of carbon atoms. And then some of the carbons form rings. With hydrogens coming off of those. So they're all carbons with hydrogens, but they're different sizes. So the challenge for somebody who's selling this is to now separate it out, because you can't use it all at once. You just can't take crude oil and just put it in your gas tank. Okay? So the processing, I erased it, for petroleum is called refining, the refining process. And let's see, Sarah, take that piece of paper off there, would you please? And this is what an oil refinery looks like. You've probably, have any of you seen these when you're in like industrial areas? Around here, you might see some down in the Wilmington area. They tend to be close to seaports because that's where it's cheap. It's always cheapest to transport something by boat. So a lot of petroleum is shipped in gigantic tankers. Some of them are at the ends of pipelines. So I think we got a couple in Greensboro. There might be some of those. But if you go up to New Jersey, between Philadelphia and New York, between Trenton and New York City, there's a stretch of a lot of refineries there. Or down in Louisiana is where you see a lot of them because.
Are they the big white things?
No, those are just the tanks. They look like this. Gigantic silver columns.
But is the tanks what they store it in?
These tanks are what they store it in. Yeah, so you might get tanks where the crude is stored, and then it goes to the refinery, it's refined, and then it might get distributed out into other tanks. Okay. But basically, here's the process. You start with the crude oil, and it gets pumped into this column. What you don't see here is there's also a source of steam. Very, very hot steam that is being driven at the bottom of this column. So this column here, that's a diagram of one of these things. And you see the little things coming out along the sides. Those represent these different stations. The other thing, you don't see the terminology here. The functional part of this thing is called a bell cap. Bell cap. So these little things here are called bell caps. So you'll have the side of your column here, and then you will have these sections that look like this. And these are called bell caps. And then you'll have the next layer up, so they come in layers. And what happens is that crude oil is driven up in this hot burst of steam and is carried up through these holes here. And what happens is if it's a small carbon compound, it will come up, it'll hit the bell cap, and then it'll keep going up. If it's a larger component, like a lubricating oil or something that has many carbons in it, it won't have enough force to continue moving up, and it settles into that current at that level, and is then extracted. Okay, so the size of the molecule is sorted out by the heat and steam driving these molecules up. Does that make sense? Physically, can you get an image of what that is like? So the smaller and smaller molecules make it all the way up to the top and are pulled off. So here's butane, for example, which is just a couple of carbons. okay? So this is actually a gas. And as you go down, the number of carbons in the molecule get larger and larger. Coming out of the bottom, you got this tarry, goopy, really heavy stuff.
Which is the most expensive?
Oh, it depends on the use, and typically diesel is more expensive than gasoline, but that has to do more with economics than.
Not necessarily the process.
Right. Yeah. I mean, when you start with crude, you get all of these things, but notice, look at how the fractions build up. So gasoline is almost half of the whole volume is of the molecular size of gasoline. Diesel is another big chunk. Heavy fuel oil isn't that much. Okay. And then these get pulled off and they get distributed based upon what their use is. So gasoline will go into a tanker and those get driven to gas stations. And you've seen the tankers. You can't get through to pump your gas because there's a big tanker there offloading that particular product into the tank. Lubricating oil, you get your Pennzoil, whatever that is that you put in your tank when you're running low on oil. You can notice that's like a syrupy type. It has a very different consistency because the molecules in there are bigger, but those are all examples of petroleum. These days, too, we'll take these substances and react them chemically and produce nylon. Nylon is a petroleum product, or certain types of rubberized products. So some of the, if you're wearing nylon, you're actually wearing processed petroleum on your body. Okay. Questions about petroleum? Okay, let's move on to coal. Talk a little bit about first coal extraction. Okay. Basically, there are three ways that you can get coal out of the ground. And again, petroleum, mostly used for transportation. Coal, almost exclusively used for generating electricity. So that projector, these lights, this computer is all running on the energy that is currently being burned to produce coal, to produce electricity. The first of these, if the deposits are near the surface, you don't have to go down too far to get to them. Basically, you have heavy machinery that scrapes away the earth and exposes the coal. Coal comes in seams. I'll show you a picture of this in a minute. But if you drive through West Virginia or drive through Kentucky, through the road cuts, and you'll look at the rocks along the road, and you'll see rocks, and then you'll see a layer of really black stuff. Okay, that's a coal seam. And if there's not much above that, then basically people would come along with big bulldozers and they'll take the rocks off from that, and then they'll just take the seam right out. In the old days, that's all they do, and then they just leave it. And it was extremely destructive to the environment, this kind of strip mining. So you have you basically would dig a big pit and then put all of that stuff above the pit. Say your coal was down here. And you dig down, you take the coal out. This dirt and rock and residue that was on top of the coal would be put into a gigantic pile. This would occur, just along miles and miles of land. And this was just left. This was called overburden. And you can imagine what a landscape would look like if people just did this and left it. After people started realizing how destructive this was, because you got to take off all the trees, whatever's growing there, you got to get rid of it, and you just leave these huge gaping holes all over the place, and it would take a long time for anything to grow there. Coal often has sulfur in it, and when sulfur combines with water, it forms sulfuric acid. So you would a lot of times get, when it would rain on all of these deposits, when there's coal left over here, and it would drain into creeks, you would get what was called acid mine drainage, which was, a really serious water pollution factor. Okay, so that's strip mining. After people started realizing how devastating this was, they started doing what was called mine reclamation. They would reclaim it. And they put the overburden back in the hole. They landscaped the area, they bulldozed it, and then they would plant trees. Now, if you were a coal company, you don't want to do this because that cuts into your profit margin because it's more expensive. But any environmental regulation up front for the company is going to be more expensive. As a whole, for the environment, it's going to be cheaper from the larger perspective. Now, if the coal is very, very deep, it's too energetically, it takes too much energy, it takes too much time to get all the material that's on top of the coal off. And that's when people would do subsurface mining. And that's where you would, dig a mine shaft. And then you would basically tunnel through the seams and extract the coal in that way. Very dangerous. The mines collapse. Mining in general, underground, when you're underground, mining is a dangerous job. The miners that would do that would be exposed to all the coal dust that's in the area. Very fine particulate coal particles get very deep into the lungs. And if you have particles that go way down into the little alveoli or the bronchioles, your body, if it gets deep enough, your body has no way of getting that out. If it's still in your trachea and your bronchi, you actually have little cilia lining those areas, and if dust gets in there or mold spores, your body has a way of working that up until you cough it up or swallow it. But if it goes really, really deep, your body becomes part of you. And many coal miners would die of what was called black lung. Basically, the functional areas of their lungs would get clogged up with these fine particulate coal dust, and they would slowly asphyxiate as they got older. It's a very dangerous job. We've gotten so good at moving rock that in certain places where the coal is found in a mountain or near the top of a mountain, and this is what's occurring in West Virginia, we basically just remove the top of the mountain and get the coal. This is highly destructive. You might have your grandparents or parents that lived in a part of West Virginia, and they'd look over yonder and see yonder mountain. Well, yonder mountain might not be there anymore.
The runoff too.
Yeah, so what we have happening there, and this is common in West Virginia, for example. So here's your mountain ranges here in the Appalachians, and you might have a coal seam running through like this part of a mountain. It's not too far from the top. Well, you just take that top, you put it in the valley. All that rubble you put in the valley, and then you remove the coal. And of course, all that waste in the valley, when it rains, that valley is now filled with a mountaintop, so you're drastically affecting the water quality in the creek that drains through that valley. So a lot of people are very, very upset about this. Of course, any environmental issue has two sides. These are jobs that are being created. We're the ones who turn on the light switch and burn the stuff. using the electricity. So there's always, to every environmental problem, there is always two sides. So those are the three major ways that coal is extracted. And it's going to be with us for a while because we've got a lot of it. No nuclear disasters can happen when you're burning coal. So from that perspective, it's cheap. I want you to get an appreciation of what it takes to burn coal. So if any of you love this class so much, you could always take ENV 120. And we actually go to coal-fired power plants, and we go to landfills, and we see all kinds of neat stuff. I actually did have this. Yeah. So let's have a look at this. I want you to get a sense of what this is about. Okay. So our nearest coal-fired power plant is the Marshall Steam Plant. If you know where Route 150 is, between Lincolnton and Mooresville. Okay, go along there. The Marshall Steam Plant is right there on Lake Norman. You have to put power plants near a water source because you need water to cool things down. You need water to make steam. So this is what the Marshall Steam Plant, how it operates. Okay, so so this is what I was talking about in terms of coal seams. Okay, coal just looks like a black rock. There's a deposit you can see. If we were strip mining, we'd be taking that off and getting at that seam. So that's a coal seam right there. And right here, when the train runs, most of the trains that run right here through Hickory, if you got up a little bit higher, you'd see that. They're carrying coal to one of the power plants to be burned. This is what the Marshall Steam Plant looked like in the 1970s and 80s. Basically, you have a big pile of coal somewhere. You crush it, and there were four major boilers units. And the coal would be injected into that. You'd burn it. You'd boil water to make steam. And everything, the entire exhaust went out through the stack. And then we have the laws to protect our air quality, and we realize there's a lot coming out of those stacks that needs to be dealt with. So the majority of the Marshall Steam Plant now is all of the mechanisms that have been used to reduce those pollution sources. And as you've probably read in the newspaper, the Dan River, we had a breach of a fly ash pond that essentially poisoned large stretches of the Dan River. So there are a lot of pollution issues that come from burning coal. Just to give you a sense of the scale of this, the plant gets 100 rail cars of coal per day. So 100 of those big rail cars. On site, there's a 42-day supply of coal. So for some reason, if the railroad stopped working, they could keep generating electricity for 42 days. And the coal company spends between $550 and $560 million per year on coal. So, you know, Duke Energy has to pay that. Here's Lake Norman in the back. People don't normally think that water has a lot to do with energy, but for most of our power generation, if your water runs out, you won't be able to generate electricity anymore. There's an intake for the water that's used in the plant, and if we have a severe drought like we had in 2007, and the water level drops below the intake, you're out of business as far as generating electricity. So our electricity is dependent upon water. Here's a general outlook for the plant, and this applies things that I'm going to be talking about here, generalities of electricity generation, have to do with hydro, wind, and nuclear as well. So there are some components here that they all share. Here's your pile of coal. It goes into a bunker. It gets crushed, dried. At the point that it's injected into this thing, which is the boiler and the furnace, it's the consistency of dry talcum powder. So you know, like the powder that people used to put on their faces to powder, that fine level of coal. So you went from that big rock to this stuff that you can blow it and it would, you know, hang in the air. And that's exactly what you want to do, because you want to increase the surface area of the coal particles. You want to, remember, combustion, you're taking a fuel and combining it with oxygen. This is combustion that I put on the board last time. So you want to expose as much of that tiny particle of coal to as much oxygen as possible so you can get the maximum amount of energy out of that. That's called efficient burning. You know, you can take a chunk of coal and throw it into a fireplace and it'll take a long time. That's very inefficient because you've got a big chunk. And it takes a while as it burns for the oxygen to come in contact with the fuel. In the wall of the furnace are lots of tiny, tiny little tubes. And there is water running through the tubes. So there's a circulation of water that comes in. It starts off cold. It runs through the furnace, and as it comes in contact with those hot surfaces, it heats up to form steam. And then that steam is blown across a turbine. A turbine is it looks like the blades of a jet engine, very much like that. So the steam is blown across a turbine, and the rotating turbine, so we said that when we take a coil of wire and we rotate it inside of a magnetic field, remember that? That's what happens in the generator. So the turning axle of that turbine rotates a coil of wire in a magnetic field, and that makes electricity. That part, the turbine in the generator, is found in wind generation. It's just that instead of blowing steam, you have the blades turning. Okay? In a nuclear power plant, you're also making steam. If you're burning biofuel, if you're burning petroleum, any burning process is going to do that. The only one that really doesn't use this is photovoltaics. That's a different process for generating electricity. But this part is very much the same in lots of different ways of generating electricity. Hydropower too. It's just that in hydropower we have water coming from a dam turning a turbine.
Does this use the same water over and over and over?
Yes.
But it don't
Yes,
lose
for
any?
so it blows through this turbine and then it condenses. Now here's a separate container of water. So you have coils running past each other and they're essentially dumping heat. It's called a counter-current heat exchanger. And then that steam condenses back down into cold water and goes back to the furnace. You have to have extremely pure water to do that. A buddy of mine, he started off being a frog biologist. He worked at a zoo. Frogs and amphibians are very sensitive to changes in the water, and he was a master at adjusting the water quality in his amphibian exhibits to be of the right chemistry to help the amphibians. He was hired by our power company because he was so good with water. And now he works flying all over this hemisphere, working for power plants on how to make their water. They say if you drink enough of this pure water, it's so isotonically pure, it can actually hurt you because it robs your body of its electrolytes. You
So
don't
they don't lose any water whatsoever in this process?
Yeah, they probably, there's always there's a little bit of loss. But basically only two bodies of water here. The loop that makes the steam, and then the loop that goes, this cooling water comes from Lake Norman, cold water from Lake Norman, and it runs next to the tube that's coming from the steam, and then that heats up, that gets pumped back out into Lake Norman. So in the wintertime, when you're fishing for striped bass, people go fishing around the power plant exhausts because that's where the warm water is. Are we out of time? Okay, we'll talk more about this. This is everything that's been added on for air quality regulations. Everybody sign the sheet. I'll see you all next week.